Students, in our last lecture, we have studied the concept, the derivatives of an inverse trigonometric functions, in which we have completed the proofs of derivatives of sine inverse x, cos inverse x, and tan inverse x. Today we are going to discuss the proofs of the derivatives of cot inverse x, sec inverse x, and cosec inverse x. So let us see. First, see here, if y is equal to cot inverse x, where x belongs to R and 0 less than y less than pi, then dy by dx is equal to minus 1 upon 1 plus x square. Okay, see here, this y is equal to cot inverse x is the function given, and the condition on x is x belongs to R and y lies between 0 to pi. Then we have to prove that dy by dx is equal to minus 1 upon 1 plus x square. So see the proof. Here given condition we have written here, y is equal to cot inverse x, x belongs to R and 0 less than y less than pi. This is domain set and codomain set. Okay. So now y is equal to cot inverse x can be written as x is equal to cot y. Okay, now again, as similar to sine inverse x, cos inverse x, and tan inverse x, we write here x is equal to cot y. Now differentiate with respect to y. Then see, we get dx by dy is equal to d by dy of cot y. Now we know the derivative of cot y. See here, that is minus cosec square y. Dx by dy is equal to minus cosec square y. Now by the fundamental identity, this can be written as minus as it is, and cosec square y can be written as 1 plus cot square y. Okay. Now as cot y is equal to x, we get dx by dy is equal to minus of 1 plus x square, since cot y is equal to x. Okay, so this is just an adjustment here. Dx by dy is equal to minus of 1 plus x square. So now as we required the derivative of cot inverse x, here this is the derivative of cot y. So by that theorem, dy by dx is equal to 1 upon dx by dy, and hence we get dy by dx is equal to minus 1 upon 1 plus x square. So this is the proof of this result. So now onwards you always remember, as a standard inverse trigonometric function, the derivative of cot inverse x is minus 1 upon 1 plus x square. So see this proof carefully. Okay. So proof number 4 is completed, as just we have completed 3 proofs in our last lecture. Now fifth one, if y is equal to sec inverse x. Now sec inverse x is the function such that modulus of x is greater than or equal to 1. See the condition on x, means domain set, and 0 less than or equal to y less than or equal to pi. This is the condition on y, but y is not equal to pi by 2 in particular. Y is not equal to pi by 2 in this interval. Then prove that dy by dx, means derivative of sec inverse x with respect to x, is 1 upon x into root of x square minus 1 if x greater than 1. So now we will try to prove this. So first of all, write the given condition as it is there. See here, this is the given condition. Now again, we get x is equal to sec y. Okay, so differentiate with respect to y. So dx by dy is equal to d by dy of sec y. Now see the derivative of sec y with respect to y. So that is dx by dy is equal to sec y into tan y. Okay, so this is the derivative of sec y. Now here we will adjust this term like this. See, we have written sec y as it is. Now tan y can be written as under root tan square y and plus or minus sign here. Plus or minus sec y as it is, and as we take this tan y as root of tan square y, we have to write plus or minus sign here. Okay. Why we adjust like this? Because we know that plus or minus sec y tan square y can be written as under root sec square y minus 1, because we know the value that is sec y as x. So further adjustment is possible here. That's why we have converted into this form. Okay. So we get dx by dy is equal to plus or minus sec y as sec y is replaced by x, and here we get x square minus 1. So the derivative that we have uh, calculated is in this form, that is plus or minus x into root of x square minus 1. Now we have to decide whether it is plus or minus depending on the given condition that 0 less than or equal to y less than or equal to pi and sec y into tan y. So see here, what will you write? Now in first quadrant, both sec y and tan y are positive. In first quadrant, how will you decide first quadrant? Because this is the condition. 0 to pi means which quadrant? 0 to pi by 2 is first quadrant and pi by 2 to pi is second quadrant. So in first quadrant, first of all we will see the nature of sec y and tan y. So in first quadrant, sec y, tan y both are positive. Now think about second quadrant. In second quadrant also sec y is positive. See, sec y is the reciprocal of sin y. So sin y is positive, so sec y is positive. And sec y and tan y both are negative here. In second quadrant, sec y and tan y are negative. Sec y is the reciprocal of cos y. Okay, and cos y is negative. So sec y is negative. Similarly, tan y is also negative. So in first quadrant, both sec y, tan y are positive, and in second quadrant, sec y and tan y are negative. So the product means sec y into tan y is positive in both first and second quadrant. So if we think about first and second quadrant, then we conclude that this derivative, that is sec y into tan y, is positive in both the quadrant. So the condition which is given to you, 0 less than or equal to y less than or equal to pi, in that sec y into tan y is positive. So here after the adjustment we have taken plus or minus sign here, but now see here. So for x greater than 0, x into root of x square minus 1 is positive. Also, when x is less than 0, minus x into root of x square minus 1 is also greater than 0. So see here, always here this positive means if you take positive sign here, then this is greater than 0. Also if you take minus sign here, then when x is less than 0, it is also positive quantity. Okay, so what will you get? Dx by dy is equal to, if you write plus x into root of x square minus 1, when x greater than 0 or modulus of x greater than 1, that is x greater than 1, because the condition is given, that is modulus of x greater than 1, but here we take x greater than 1 for that case. So we can take dx by dy is equal to plus x into root of x square minus 1. Similarly, we can take minus x into root of x square minus 1 when x is less than 0, modulus of x greater than 1, that is x less than minus 1. Means there are two conditions. Modulus of x is greater than 1 means what? X greater than 1 and x less than minus 1. So when x is greater than 1, we get this, and when x is less than minus 1 we get this. But both these are positive. This expression is also positive and this expression is also positive. Okay, so what is dy by dx? So dy by dx is equal to 1 upon dx by dy. So we get dy by dx is equal to 1 upon x into root of x square minus 1 if x is greater than 1, means this condition. See, both these derivatives are positive, means because x is, when x is less than minus 1 all numbers are negative. If you put here, then all this quantity become positive quantity. So dy by dx is equal to, we get 1 upon x into root of x square minus 1 if x is greater than 1, means this condition. And you will get minus of 1 upon x into root of x square minus 1 if x is less than 1, means by this condition. Okay, so see here, this is these are two derivatives, dy by dx, when x greater than 1 and when x is less than minus 1. Now there is a note that a function is increasing if its derivative is positive and is decreasing if its derivative is negative. Increasing decreasing function is the concept uh, related to the function, and when the function is increasing if the derivative is positive, and when the function is decreasing when the derivative is negative. So remember this, in applications we will study in detail. And the second note is, the derivative of sec inverse x is always positive because the graph of sec inverse x is always increasing. Means in short, if you want to remember, then sec inverse x is always an increasing function. Then what about the derivative, and when it is possible, when the derivative is positive? So here we get the derivative as 1 upon x into root of x square minus 1, and another derivative as minus of 1 upon x into root of x square minus 1. But due to this nature of the graph of sec inverse x, that is sec inverse x is, means graph of sec inverse x is increasing, that's why it is the derivative is positive always. So that's why we take the derivative for further reference. The derivative of sec inverse x is always equal to 1 upon x into root of x square minus 1 if x is greater than 1. So now onwards you just remember that the derivative of sec inverse x is always 1 upon x into root of x square minus 1. Okay, because of this condition. So we have completed the proof of the derivative of sec inverse x here. Now what about cosec inverse x? See here, if y is equal to cosec inverse x is the function given, the condition is modulus of x greater than or equal to 1 and minus pi by 2 less than or equal to y less than or equal to pi by 2, where y not equal to 0 in particularly. Then dy by dx is equal to minus 1 upon x into root of x square minus 1 if x greater than 1. Means we have to prove that the derivative of cosec inverse x is equal to minus 1 upon x into root of x square minus 1. Okay, so write the given condition as it is. Now the function is y is equal to cosec inverse x, so hence x is equal to cosec y. See here, x is equal to cosec y. Differentiate this with respect to y. Then what will you get? See, dx by dy is equal to d by dy of cosec y. So see the derivative. So dx by dy is equal to derivative of cosec y is equal to minus cosec y into cot y. See here. So this is the derivative. Now we will adjust this. So how will you write? See, this minus sign is as it is. Remember, minus sign keep as it is and adjust this term only. So how will you adjust? Cot y can be written as plus or minus under root cot square y, cosec y as it is. So see here, how will you write? This minus sign again keep as it is, plus or minus cosec y into cot square y can be written as under root cosec square y minus 1. This is by fundamental identity, and hence we get this minus as it is, and in bracket plus or minus x into root of x square minus 1, since cosec y is equal to x. So we have completed the derivative of cosec y, and we have formed that derivative like this, minus of this. Now we have to decide whether it is plus or minus. So we will discuss the conditions here. So now as see, minus pi by 2 less than or equal to y less than or equal to pi by 2. So here the quadrants are first quadrant and fourth quadrant. See, up to pi by 2 it is first quadrant, and up to minus pi by 2. Minus pi by 2 means you have to measure the angle in clockwise direction. So we will get the fourth quadrant. So we have to decide the sign of the cosec y into cot y. So in first quadrant, think about this, cosec y and cot y are both positive, okay, in first quadrant. Then in fourth quadrant, cosec y and cot y both are negative. See, cosec y is the reciprocal of sin y. Sin y is negative in fourth quadrant, so cosec y is negative. Similarly, cot y is also negative. So the product cosec y into cot y is always positive in both first and fourth quadrant. So see here, cosec y into cot y. This minus sign is as it is. Remember, only think about cosec y into cot y. This quantity is positive. See here, minus sign as it is. Remember, it is separate. Just you decide that cosec y into cot y is positive in both first and fourth quadrant as per this condition. Remember. So when x is greater than 0, x into root of x square minus 1 is greater than 0, and when x is less than 0, minus x root of x square minus 1 is also positive. Now we have to decide plus or minus sign here. So see, what will you write? Dx by dy. The original minus sign is as it is. Now we will write plus sign here, plus of x into root of x square minus 1. So what is the condition on that? X is greater than 0, modulus of x greater than 1. In that we have taken x greater than 1. Then this is positive. See, this bracket is positive. Remember, what is this? This is nothing but cosec y into cot y. Minus sign keep as it is. So cosec y into cot y is positive. So this is the positive because of this condition. Okay. Now again see here, this is minus as it is. Now in bracket, see this quantity and the condition. See, when x less than 0, modulus of x greater than 1, that is x less than minus 1. Again, as per that cosec y into cot y is positive, this quantity in the bracket is also a positive quantity. See, because of x less than minus 1. So this is positive, this is also positive, and minus sign is given here also and here also. Okay, due to that derivative. Okay, so just think about the bracket. In bracket, this is the positive quantity, and in bracket, this is also a positive quantity, because cosec y into cot y is positive. Okay. Now what about dy by dx? So we get dy by dx is equal to 1 upon dx by dy. So as per this given, first of all, for this condition, that is x greater than 1, how will you write it is? See, minus of plus, minus into plus means minus. We get minus 1 upon x into root of x square minus 1 if x greater than 1, and it is equal to 1 upon x into root of x square minus 1 if x is less than minus 1. See, for x less than minus 1, it is minus of minus. So it becomes plus. Okay, so when x is greater than 1 we get this derivative, and when x is less than minus 1 we get this derivative. But again here the note is given that the derivative of cosec inverse x is always negative. Remember, always negative, because the graph of cosec inverse x is always decreasing. So graph is decreasing, then the derivative is negative. Okay, so decreasing graph, increasing graph, that we will study in applications of derivative. Okay, but just to remember this, you remember that the derivative of cosec inverse x is always negative. So we will write the derivative as dy by dx is equal to minus 1 upon x into root of x square minus 1 if x greater than 1. Okay, so now onwards you remember the derivative of cosec inverse x is this minus 1 upon x into root of x square minus 1. So all the important standard inverse trigonometric functions derivative are completed here. So you just remember what is the derivative of sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. See all the proofs. Okay, and remember, so I hope you have understood all these proofs. Okay, if you have any doubt, then you can contact me on my personal number. Okay, thank you.